Good evening, everyone. Welcome back. My name is Sachin Sharma. I'm the Director for Alliances and Partnerships at FirstUniv and your moderator for today's session. We've been doing this for a couple of weeks now, and I think with every session, I hope we all go back smarter. And I think the Q&A sessions really help us all to sort of navigate our future in the industry of AI and ML. Today, we are going to talk about reinforcement learning. It is one of the hottest topics in ML today, and RL, short for reinforcement learning, is a type of machine learning that enables a computer system to make choices by being rewarded for its success. RL is a key focus area in video game development, and big studios like EA, Rockstar spend millions of dollars on these technologies. So in short, today we're going to talk about video games. And joining us today are Dr. Kushal Kanwar, a PhD from Punjab University, Chandigarh. He has also qualified for his GATE and UGC NET. Dr. Kushal has been teaching for many years now and has helped countless students achieve their ambitions through his teachings and guidance. As an active researcher, Dr. Kushal has published papers in AI and complex systems. So welcome, Dr. Kushal. Very good to have you back. And pleasure, sir. And joining us for the first time is Sachin Sharma. Sachin is the CTO and co-founder at Learnins and aaddoo, and also runs the FirstUniv platform. AI and ML degree from Purdue University and a Bachelor of Engineering degree in Computer Science from Himachal Pradesh University in India. I work very closely with Sachin, and it's a great honor for me to have Sachin here today. So with that, I pass it over to you, gentlemen, and thank you.
Thanks a lot, Dipit. Hi, everybody. Hi, Kushal. I will share the screen, the presentation. So, yeah, that's good. So, good evening, all. So, I will start with the presentation. So, today we have a very interesting topic called reinforcement and with application to video games. So, why video games, first of all? So, video games. We will learn through this webinar how video games can help standardize in the real world environment. So I will start with the presentation. I will pass over this slide to Dr. Kushal.
Okay, thank you, Sajita. So hello everyone. So first of all, we must know what is reinforcement learning. So reinforcement learning is a type of machine learning along with other types of machine learning. So how the machine learning differ from other types of machine learning? So this is basically something which is actually very close to the AI which we want to build. Okay, so in machine learning, in this reinforcement learning, what happens is we create like game-like situation where there are agents and there is environment. And when you have agents and environment, then you have the concept of state, that your agent and environment are living in particular state. Then they take some action and the states get changed. They move to the next state. And on taking the action, you will be rewarded positively or negatively. So based on these rewards, the agent is going to learn some policy, that what actions he must choose. And by learning these actions, he actually learns a policy. Okay, so that is the main crux of reinforcement learning, that in reinforcement learning, we learn a policy by doing these repeated trials in our environment. And once the policy is learned, so agent learns how to behave intelligently with its environment. Even if you put it to the similar environment where it was not trained, so it is going to behave very intelligently. Okay, for some actions, he will guess that what reward I can get for this action, and it can do very wonderful tasks. Like in video game, for example, gaming engine trained for a particular environment. When you deploy it in another environment, it is going to give a very good user experience. So like user which is playing against the agent, it will feel very nice that agent is giving him real challenge. So that is the reinforcement learning, and in particular to the flavor of this video game play. Okay, so this is the basic definition of this reinforcement learning, right? So these are the four things which we are going to have: a set of states, a set of actions which agent can take, and a probability matrix from on the basis of which agent can transition from one state to another state. and reward associated with each move, each of his actions. Okay.
So yeah, thanks a lot, Dr. Kushal. So again, Dr. Kushal spoke that in a term of basically how using various techniques you can implement reinforcement learning. So there are the parts of reinforcement learning. So to make it more easier for our layman audience, so these are the key terms which Dr. Kushal used when he was speaking. So first was the environment. Environment means basically the physical world. So whenever you play a game, if I take example of a PUBG, so environment means different maps on a PUBG. That's the environment basically, and that environments have different states. States mean when you hold a gun, when you are holding a gun, or when you are when you are shooting, or when you are ducking, or when you are sitting. These are the different states of that agent. Then we go to the reward. Reward means when reward. So Dr. Kushal, can you put some light on the reward and policy?
Like for example, if you you are playing Counter-Strike and you killed a player, okay, so your score will go up, your kills will go up, okay. And for example, if you are playing chess against a bot, so if you kill his chess piece, so you will get a reward for that. If you are playing some game like Farmville kind of game, where you deploy some very good strategy against machine, and you get some reward that your points go up. So that thing is reward.
Great. And the policy, basically, these are the different mapped actions. So when, like Dr. Kushal said, in a chess, okay, in a chess, when you move forward, when you move forward 2.5 steps for a horse, when you move forward, so that are the different policies that that particular piece can move this much. That's a different policy and actions. Then there's a value. This is very interesting. We will learn in the future in this webinar. So like, if a current agent is at a particular state, so like let me explain, put it in a very easier way. If two AI players are playing chess against each other, then the first AI player A, has to understand how taking a current action you can get, what is the value in that in future. That's the value, future award for that agent. So how he can, if he can surrender a piece, or he can take over the piece of the other opponent. So you have to take decision on the future. That's a future award. Value means that agents, you have understood, agents are the AI players who are playing that game using all these rules. So let us again explain this, what we said, what's a reinforcement learning environment, how it works. Dr. Kushal, over to you.
Okay, so as we know that we have discussed that there is going to be some environment, there are going to be some agent, and agents are going to work according to some algorithms, and they are going to change their state, and for each state they are going to be rewarded, and they are going to produce some output. The output is what? It is policy. And if this pictorially represented on this slide, you can see that you have some raw input data. That means you have the starting states. Then agent starts the trial with the environment. Okay. So it is going to take some actions, and it is going to move some pieces around, or it is going to move around the system, depending upon the scenario, depending upon the environment. But your environment offers the constraints and the flexibilities it offers. Then on the basis of your actions, you are going to get some reward. And agent is going to actually log that on taking particular action, I am being rewarded like this. Okay, so when it is going to do it repeatedly, so it is going to learn that what sequence of action should I take, okay, to get rewarded positively. So it learns the policy. So that is how you get your output. Okay, so that is the gist of this pictorial gist of our discussion so far.
So now, enough this reinforcement learning background, let's move straight to the main topic, how reinforcement learning is used in video games, and why we have taken video games as a topic for today. As I said in the start, video games, implementing reinforcement learning through video games can teach a human being to create different strategies in a real world environment. So if I give you an example of a current hot topic going on in the world, I can't say hot topic, but the war with Ukraine and Russia. So you can implement reinforcement learning on that scenario and come out with many strategies, and which can be implemented, or maybe Russia or Ukraine are doing that using reinforcement learning. They are implementing many strategies on the field. So this is how reinforcement learning implementing using video games can teach us the various strategies in our real world scenario. So this is a 2-minute paper. So what is a 2-minute paper? So Dr. Kushal, can you lay?
Okay, so let me explain about this. So there is a YouTube channel. Its name is 2 Minute Paper. So what the host of the channel does, so he goes to very good conferences, right? Like International Conference on Learning Representation, Computer Vision and Pattern Recognition, AAAI, and Neural Lips. He goes to such conferences. He picks out some paper, and in less than 5 to 7 minutes, he tries to explain what the paper offers, so that user get a gist and it doesn't get bored. So that is a very good place where you can get the summaries of latest paper, what is happening in the field, state of the art. Okay, so that is about what is the 2 Minute Paper.
Thank you. So we'll start with a game called hide and seek. This was implemented in a 2-minute paper. So I've taken this example for this webinar. It's a very basic game, and through this game you can understand how it can be implemented on a more complex environments like PUBG or StarCraft or Atari or AlphaGo or chess. How can it be implemented? So I will start. Let me explain. I think everybody knows what the hide and seek is. So the red guys are the seekers and the blue guys are the hiders. So these red guys has to obviously look for the hiders. The seekers have to look for the hiders. Red guys have to look for the blue guys, and blue guys have to hide away from the red guys. So now we come now if we recall the slide which I shared, this is an environment. This is a box, you can say environment. These are the objects are the small boxes are the objects, the ramp and 2 boxes, and then the actions are when a red guy sees a blue guy, he gets a positive point. He gets a positive reward for that. And if a blue guy is seen by a red guy, then he get a negative reward for that point. So the point is how many the red guys, they have the aim to get more and more rewards, and the blue guys have the aim to get more and more rewards to win the game. Let's start with the video. I think this is the crux of this hide and seek game. I think we have all played, and if you remember, we have all played. We used to close our eyes and count to 1 to 10, and then our friends used to hide. It's the same game. How the reinforcement learning has been applied here, and what we learn from it, that we will learn in next few minutes. First of all, I need to again reiterate these 4 guys which you can see, red and blue, they are totally AI based. They are totally AI based. They are AI agents, absolutely, and they have currently no intelligence. At the first step, they are non-intelligent agents because they don't know what to do. They have just set of rules. Now we will see gradually how they learn during when they play, or when we play this program, or when we reiterate this program, how they play. So I will play a video. So this is how they play. So this is a 2-minute paper. So let me first, this paper was given by Bowman Baker. So obviously I want to give them a credit. These are the names for those papers. And if you want to search, you can go on YouTube and look for a 2-minute paper, and you can find so many games depending on, and this is basically, this is by a company called OpenAI. They pay these researchers a lot and to come out with these strategies and these games to implement on a real world scenario. So as you can see, Dr. Kushal, can you lay some points on these rules?
Okay, so there are some rules. For example, there is a red guy. He sees a blue guy, so he's going to do, his point will go up. And similarly, this blue guy will get a reinforcement that he's being seen by the red guy. Okay, so what he has to do? So he has to change his position. He's going to hide behind the box, or he's going to go towards the wall and such kind of stuff. Okay, and similarly, the red guy, when blue is moving away from his side, so he will position him in such a way so that he can see him. So this is a very crude way to put it, that how they are going to be rewarded. So they are going to change their position constantly so as to optimize their cost function. Okay, so what is their cost function? Reward function. They want to be positively rewarded. Okay, so they want to avoid the punishment of getting negative points.
So I want to add, yes, I want to add to it. So now you can see that I've given you 3 rules. These are rules. Basically, the agents can move by setting a force on themselves in X and Y direction. They can move in X and Y direction. This is how we create a reinforcement algorithm or program. Okay, so we will give the agents a rule. So what they can do, the agents can move in X and Y direction, and they can rotate on the Z axis. Then second, agents can see their objects in a peripheral view. There's a cone shape, as you can see. a cone shape view. This they can see these agents, and when a red guy sees a blue guy, he gets a reward, and blue guy get a negative reward for that. Same, the last is the agents can sense using a sensor, so they know how much distance they have to walk, so they so that they don't collide with the objects and the walls. So they have a lidar sensor, a type of rule given to them, so that they can count the tiles, so that they can know they have to move 5 tiles and then there will be a wall. So they don't want to go to that side. That's how it starts. Okay, so now you can see these are rules. Move it forward. Then second set of rules are agents can grab and move the objects. There are also rules given to them that they can grab. Both the agents, blue or red, they both can grab the objects and move around with the objects. And second is agents can lock the objects in the place, and only the team who has locked the object can unlock it. So let's see how it goes. This it starts now. It starts here. So it starts. So this I want to explain. So when this game was started, so when this program was played, so for about a million moves. So I talk about million moves. Million moves doesn't mean, so for a human being to learn million moves will take, Kushal, weeks or months for a human being to learn, maybe years, right?
Yes.
Yeah. So for a human being to learn hide and seek from scratch, with the help of million moves, it will take a year, or as Kushal says, more than years to learn. But a million moves done in a reinforcement algorithm can be completed in a hour time or a 2 hour time with a proper
simulated environment. Yes,
absolutely. For million moves, these, as you can see, these guys were going here and there. They didn't know what to do. They have no idea. They have no clue, because they were non-intelligent agents. They have no clue. They were going here and there. And fortunately, the red guys were able to find the blue guys, and they were winning. They were winning. So after 100 billion moves, about more 100 billion moves, the blue guys thought that why we are losing. So they formed the strategy. So I have again reiterate, these were non-intelligent AI agents. They were not AI, they were non-intelligent agents. But after 100 million moves, look what they did. They understood, okay, fine, we have to lock the door and we have to block the passage. Now they started winning. So now the blue guys started winning. This is how a reinforcement learning works. So now the blue guys have learned to win. Now they are getting reward points for that, and red guys are getting negative points for that. So again, after a million moves, this kept on going, and this kept on going. Everybody thought that it's over now. What to do? So then red guys was losing. They were losing after 100 billion moves. Something else happens. Let's see. There was a clamp there. So again, I have to reiterate, these were non-intelligent agents. After doing the iterations on the moves, they were learning through their rewards. Now the red guys were losing. So they thought what to do. That, okay, fine, there is a ramp. What can I do with the ramp? Okay. And here it goes. The red guy takes the ramp towards and jumps over it and starts winning. Bang, it starts winning. So this is how a strategy is formed. This is called strategy. The red guys learned through reinforcement learning how to create a strategy. Blue guys created a strategy by reiterating through the different steps, by rewarding, by policies. They learned to work together to block the doors. But then the red guys learn another strategy, but how to use the ramp to basically win over the blue guys.
So here in this environment, particularly the environment can be modified by the agents. And in some situation, we can have the environment where agent cannot modify the environment.
Yes, absolutely. So this was modified. So now I want to go to the last part of this game. So now everybody thought this game is over. The red guys are winning. So if you remember, I told in the start, hide and seek. In the start, a person who is seeking has to close their eyes and count till 10. So everybody hides. So it's just in the same rule is there. So for particular 1 or 2 seconds, the red guys are frozen. So in that second, a strategy was formed by blue guys to hide the block from red guys. And they started winning again. How cool is that? So this is how a program has developed, and has become after 480 million moves. after this is the result after 480 million moves. And Kushal, can you tell me 480 million moves reinforcement program, how much time it will take?
So like on a faster CPU, it can do, like faster GPU, it can do within hours.
Within hours. And for a human being to do a 480 million moves in his head, so how many years it will take?
It will take many lifetimes.
Many lifetimes. Now you can understand by implementing this, we are learning how AI-based reinforcement learning can help human beings in a real-world scenario to learn the strategies which will take them years to learn. So this is how video games, implementing reinforcement learning through video games, can teach a real-world scenario. This is how you can see now they started winning again.
See, we can see that by having these 4 or 5 simple rules, and with like many number of trials possible, we can do wonders. We can see that the agents have become really intelligent. They have learned something from their environment. And this is happening why? Because we have allowed this mathematical system to evolve over time again and again. So it will form some pattern.
Absolutely. So going to the next screen. So Kushal, can you explain a little bit about the policy architecture for this?
Okay. So
Sachin, before we go ahead, I think I just wanted to check if there are any questions, because that was very interesting. And if there are any questions in regards to this, I think now
I saw a raised hand. I don't know who it was.
Okay, I think it's question. If there is any question,
I think we're good. So I think we can continue. Thank you.
I see Ishita raised a hand.
Ishita, if you can hear us, is there anything that you want to ask?
Okay, fine. Okay, fine.
I think probably later. Thank you.
Done. Thank you.
So let us look at the right side of the picture first. So you will say that that you are going to have an agent, the blue one, and the red one, and there is a wall, and something is behind the wall. And what is happening? They are sensing their environment. First of all, so how they are able to sense the environment. So we are going to use, if we deploy them in real world scenario, so we can say that convolution neural networks are the eye for the agents in today's time. Okay, so what they are going to do, they are going to sense the environment. After that, there is something which is, these are some technical terms like self-attention, mark self-attention. So for time being, please bear with them. So they are going to do what? They are going to pass through a layer of neural network. After that, it is going to perform some convolution, average and max pooling operation. Then they are going to feed it into a special type of neural network. Its name is LSTM, long short-term memory. And basically it is for the sequence to sequence model. And whenever we are going to talk about reinforcement learning, then there is something, the policy is what? It is a sequence of steps that we want to learn. That's why there is a LSTM, or there can be a gated recurrent unit or a modification of LSTM. Okay, so this is going to produce the behavior that what the agent should do, what action it should do. It should do the move action, it should do the grabbing action, or it should do the locking action. Okay, so this is how it is happening. And if you see inside these layers, so these things are there. That there is a lidar sensor which is going to take the vision into the capture, that what is in front of it. And then it is going to sense its environment with the help of that it has its friends, its cooperating agent with it, or it is going to have adversary in front of it, or it is having in front of the object in front of it. And these all information is passed in a simplified form to the LSTM. Okay, because LSTM cannot directly process the image, so it will take a summary kind of thing, which is produced by these convolution and average pooling. And after that, it is taking appropriate action, and that action is feedback to the agent actually, so that he can improve his behavior for the next step. Okay, and since these, and the thing is that why we are going to take so many operations, because see, when you have sequence to sequence model like LSTM, so the issue with them, they are slow and they need a long run of trials. That's why we are having that many number of trials, that 150 million moves. That is the reason for that. After that, when you play these games long enough, so this your LSTM will be trained well, and after that it can take very good actions, that very intelligent actions. Okay. So over to you. You want to explain?
No, that was well explained. So I just want to put 2-3 points. So everybody must have seen a movie called Matrix. So there, the Neo can learn to ride a bike in 2 seconds or 3 seconds, 4 seconds by running a program. So that was the reinforcement program, if I speak. And this is how our credit directors were. The matrix came around 10 years back, and they were able to train a human being by running in his mind the reinforcement program, and he was able to learn to fight kung fu, he was able to ride a bike, he was able to ride fly a plane in few seconds. So it was like, it was a kind of a reinforcement learning, the way I see. So this can happen in future also. So now why? So something serious. So why we are doing this? Why we are implementing video games? Why we are doing so serious stuff and implementing on video games? So first of all, we have to understand, we can using reinforcement learning and using this multi-agent policy or environment, we can solve a lot of complex problems which are in the real scenario. As I talked about the war going on in Ukraine and Russia, maybe they are using, Dr. Kushal, I think they can be using reinforcement learning to predict.
Definitely, artificial intelligence is also in fashion in warfare, modern warfare.
Yes. So
definitely
they can be learning the different, predict the outcome of different strategies. We can implement that. So that's then how this can help. This can really help to mimic the human behavior, how a human can behave after 480 billion moves or million moves, how a human can behave. And then human can learn in a day, which he can learn in many lifetimes. So that's what Kushal said. Again, to put some, Kushal, so Kushal, do you want to take this?
Yes, we can see that when we are going to deploy this reinforcement learning in many places, so we are going to get new insights about many things. For example, recently reinforcement learning is deployed for understanding how the cancer grows. Okay, so there is a game between the biological cells which are mutated, that is cancer, and the healthy body cells. They are fighting each other. Okay, so what is the reward for the cancer cell? They want to spread, and what is the reward for healthy cells? They want to preserve themselves, and they want to stop the growth of cancer. Okay, the body defense mechanism of the body. Okay, so these people are trying to understand that with the help of reinforcement learning. They have simulated this thing. So this is going to be a very big through if the people succeed, if they map the disease progression of cancer, so they can surely devise a strategy to stop it, or at least slow it down. Okay, if they learn this policy. Okay, and when in the real world scenario, the human society is being organized in such a manner that there are going to be many players. Always in an organization, there are going to be many groups, many players, and when you do trade, in the trade there are going to be multiple parties. They are going to interact with each other, and sometimes we cannot deploy game theory directly because like we don't know the strategy other person is going to play. So we have to go for the simulation, and for simulation, the best thing is that you aid your agents with reinforcement learning, so that given in the beginning with no intelligence and simple possibilities of the moves, it become intelligent over the time. Okay, so this is how the reinforcement learning is going to take us to the new heights. Okay.
Yes, absolutely. I want to add to that. So we need to be clear. So it's not necessarily that reinforcement learning, the outcomes of reinforcement learning can be intelligent outcomes, but outcomes can be more efficient. You have to understand that the outcomes from a reinforcement learning algorithm can be more efficient than an intelligent outcome from an AI-based algorithm. We need to understand that. So some of the outcomes they can be. So we need an efficient outcome or intelligent outcome that we can decide. Or reinforcement learning can also basically, as the last line says, it can solve the how we can create a human brain, or how we can create a human level intelligence. So it maybe in future reinforcement learning can
general AGI. We are talking about artificial
intelligence. Absolutely. So the next slides, let's see some of the applications. So I've done 10 real application of reinforcement learning. So I will focus on the 5 most reinforcement learning, and we will break them into each have to. The first is application in self-driving cars. So everybody knows about Tesla cars. They are the self-driving cars. There's the Google cars coming out, self-driving cars. How reinforcement learning is part of a self-driving cars, how it's application for self-driving car. Dr. Kushal, you want to put some light on this?
Okay, so again, in the self-driving cars, what is happening that you are in an environment where you can sense the environment, you can move around the environment. If you go outside the land, you will be rewarded negatively. If you keep driving in a correct manner, don't collide with other, you will be rewarded in the positive manner. And again, the convolution neural network is going to be the eye the machine or the camera. It is going to take in the information, complete it, made it into the simpler form, and that will be fed to some other network, that fully connected layers or some other network which can recognize and give you the intelligent outcome that you should go left, go right, you slow down, you keep the same pace. So this is how this thing is working.
This is really great. So this is really amazing when I see this. So if the people, everyone knows about PUBG. So if I have a intelligent car in PUBG, so I think I don't have to ever get out of the car and have to kill somebody. I can win the game through an intelligent car in a PUBG. I think, Dr. Kushal, we can create those agents for PUBG, for games like PUBG, right? We can create those
Yes,
agents and make them play in a real world scenario, right? Through
yes,
a reinforcement learning. Great.
So there are some questions are coming up.
So you want to take the questions? Okay, fine.
Okay, so Sudhanshu is asking, how can we practice reinforcement learning in real life? Okay,
so we will be coming to that right after 2 slides, Dr. Kushal.
Okay,
Sudhanshu, right. You have to wait for 2 slides. We will answer that question. So can take that time. We have given we will be showing the steps for the how to learn or how to go forward with the reinforcement learning. Dr. Kushal will be explaining how to create an environment. We will be coming to that in 2-3 slides. So can we move on?
Yes.
Okay. So next is industry automation with reinforcement learning. So industry automation, what do you mean by industry automation? So by
like packaging and
yes. Okay. This is the industry automation where Google has implemented in the data centers. We want to put some light. So how a data center, what is data center first? Our data center contains a lot of servers, a lot of hardware, and a data center has a lot of heat dissipation. So to control that heat, we need to cool the systems, but it requires a lot of energy. So how Google use reinforcement learning to implement cooling off and save thousands of millions of dollars by implementing a reinforcement learning cooling strategy. Now, how did this that they created an agent. The agent took all the snapshot of various parameters of the humidity, of the temperature, of the timing, of the events, and then it kept on learning. And after learning, then the agent knew when to beforehand only that now agent can predict that this server will be going to heat up after a few minutes. So it will deploy the coolant beforehand so that the server will be at 50 degrees Celsius only, and it will go down to 0 degrees Celsius. It doesn't have to deploy when a server goes to 100 degrees Celsius. So the coolant will be deployed by the agent beforehand. So agent basically can predict the heat of a server. That's how cool it is. So using this, Google saved thousands of millions of dollars, and now it is being used, I think, in all the cloud data centers across the world. So do you want to put some more light on this?
I want to give a more relatable example. For example, in Amazon warehouses, the issue is of efficient usage of storage space. Okay, so what Amazon is doing, that they are not deploying any human to store the objects. They have deployed robots to store the objects, and that is based on reinforcement learning. Time and again, the robots have started placing the objects in racks and stacks, and eventually the robots learn that how to put objects so that they can occupy minimum space, and they can be retrieved in minimum time. So that is an example of reinforcement learning, that the robots, they learn how to stack the objects into the warehouse and how to efficiently retrieve them. And similarly, when we talk about this Google data centers, so there are agents, so they are learning by their action if the overall temperature is going up. So the agent will think that I have to revise this strategy. I'm negatively rewarded. And if by taking some particular action like controlling or the regulating the signal, everything is going fine, so the agent will see that as a positive reward, and it will stick with that action. So with the reinforcement signal from the environment, that is positive reward or negative reward, agent is going to constantly change its behavior. It is going to learn the policy that how should I behave with the change in the environment.
So you are saying that if we implement this industrial automation to our home automation, so this robot with a reinforcement intelligence can predict my chores and do it before I want to do. Can it?
Yeah, it's highly likely. It is highly likely, and some of the companies are working towards it.
Wow, that would be really helpful. Thank you. So next is the this application trading in finance using supervised learning time series. So I think Dr. Kushal is the specialist in time series models. So Dr. Kushal, can you shed light on time series models? Yes.
Okay, so see, when we see the stocks, that the stocks can go up, they can go down. They have the effect of seasonality. They have the effect of trend and events happening around. So if we have the data, enough long data of the time series with us, so we can train many models. Like we can train AR model, MA model, or EMA models. Recently, what is the trend in this time series modeling? That we want to use neural networks, and especially we want to deploy reinforcement learning for that. Okay, and that is why that, because these time series are very chaotic in nature. Okay, they do have some patterns, but sometimes the human eye miss those patterns. But if you give a machine enough number of trials, and if you give it the simple set of rules, so it can learn, it can unearth what is the underlying strategy, what is the dynamics of the system. It can learn that. Okay, so that is the reason why this time series modeling is being aided by reinforcement learning and this complex agent method.
The way I understand is that if I talk about Himachal, so Himachal government can predict the flow of tourism, and they can stock the products according to that, and they can predict basically the how at what time tourists will be increased or it will be less. Can it happen? Can it happen?
It can happen. It can happen. Already there is data in public domain, and there's been information that the people have done this. So the government can do the forecast very easily. Then they can see how many police they need to control the people, how much water, electricity, or parking space they need if the place will be flooded by the people. For example, if I am going to have a reinforcement agent written by me, so I will do also check the environment, the temperature in the plains. And as we can see, there is a high temperature in the place, so people definitely will move around the hills. Okay, so there are many information. There are many reinforcement signals in the environment. They need to be combined in a complex way, an efficient way to do the forecast.
It means using time series models and reinforcement learning using time series models. If something like a pandemic occurs, then now we have enough data to predict how to stop it before it goes out of hand. Can we do that? Can it also be done?
The people are doing it. They are doing a large number of simulations, and they are trying to. They are devising. They are preparing for the next pandemic, like which usually occurs between 70 to 100 years. So people have already started working on towards that direction.
Wow, so great. Next is the reinforcement learning in NLP. So me and Kushal have worked very closely on this. Kushal from Shoolini University has, with the help of aaddoo, has developed he will be patenting it. So he has developed a reinforcement learning NLP algorithm where he can create, like right now I am speaking, and this will be converted into a text, and this text will be converted live during the class into questions, MCQ questions. How cool is that? So now teacher doesn't have to ask the question. Teacher have to give a lecture. During the lecture itself, at the end of the lecture will be created into few MCQ questions. So Dr. Kushal, can you put some light on this?
Okay, so what happens is that this is basically sequence to sequence modeling. You have sequence of words, and what is the question? It is another sequence of words. Okay, so what we have when you give a system a document, and you say the system that generate this 4 option MCQ or generate a true false kind of question. So then what is going to happen? Your neural network or the AI agent you have written, it is going to do what? First of all, it is going to prepare a document into appropriate form. That it has to do some stemming, lemmatization of stuff. After that, it will take your text and it will transform your text into appropriate manner. And if you and it is going to generate the distractors and key for you. And if you find the question is okay, this question is good, so you will say okay, it is good. So the reinforcement signal will go to your environment network that this kind of questions are okay, so I can generate more of these kind. If the reinforcement signal is negative from the person that these kinds of questions are not good, so it is going to rethink its strategy. Okay, so this is how I crudely put it. This is how we have coded this thing.
So this means if I reach a YouTube video or any video lecture, and earlier I have to note down the points. Now if I run a YouTube video or any kind of video through this program, it can give me few of the questions which are current questions from the video. So this is really helpful for a student. If a student is doing a what we call in the engineering one night fight. So he can run all those videos, this program, and get those questions from that, and he can learn those questions for the exam. So you have created a guide, which you used to call guide in my time when I used to study. It's a small guide with the questions. So you created a guide using reinforcement learning for all the videos. Great. So I think,
and if we have like previous year questions and we have access to some good textbooks, so we can also combine their knowledge and improve the model further to generate these MCQs.
This can be helpful for the teacher to ask questions during the class, and for the students to do a last minute practice of the various content. Wow.
Yes.
Great. So moving on to the question which was asked, what does reinforcement learning workflow look like? So Kushal, we want to take forward. I'll explain the next slide.
Okay, so this workflow is like there are many tools to do. So there is like OpenAI Gym, and the work and if there are some other tools also, so that the workflow is going to stay the same. First of all, you have to create an environment, and you have to define that how the agent can interact with the environment, and then you have to define the rewards, that how on what action the agent will be rewarded positively, or on what action agent will be regarded negatively, and what actions he can take. Okay, the possible actions he can take, like there was action that he can move his position, he can move blocks, or there can be environment where he cannot move the blocks. Okay, he can only change his position. Like you have to define these things, and then you have to create agent and define the behavior of the agent, that what behavior the agent can perform. Then we have to perform the train loop, that we have to leave the agent with the environment with those set of rules, and let him allow to evolve over the time. Okay, learn some policy, and then after that we will evaluate the policy whether the agent has learned it well. In the simulation which we saw in the PPT, that we saw the agents are really doing the intelligent behavior. The blue guys were learning the policy that we can move, block, and hide, and after that the red guys overcome that strategy by using the ramp. After that, again the blue guys overcome those guys by taking the ramp in and hiding away from the red guys. So we saw the validation. When we talk about validation, it can be visual validation. We have seen that visually we are seeing the agents are becoming intelligent, or there can be some functions we want to see their values minimized or maximized. Okay, and these are the things, basic things.
Yeah. So this how you how you can create a workflow for reinforcement learning. What you need to do in reinforcement learning, we've taken slide. I would again like to repeat. So I've been doing this for reinforcement learning from around 2 or 3 years. So every time I talk about reinforcement learning, it always gives me a goosebumps, because you have to understand, if you are a reinforcement learning engineer, then you are creating intelligent agents. How cool is that? You are creating an agent who will be intelligent after some training, and he will be that agent. I'm calling it he. Sorry, that agent. I will call it. The agent will be solving so many problems for us in a real world scenario. So reinforcement learning is at a very early stage, right, Dr. Kushal? It's very
right.
very beginning, because of our machinery, because of infrastructure. As the machines keep on machinery, I call about GPU, I call about CPU, because reinforcement learning needs the program which you saw, the hide and seek program, was done on a $1 million machine. It can't be done on a simple machine, because to do a 480 million moves, you need to have a machine which can carry to that. So that's why slowly the we will get new hardware, we'll get a better hardware, and reinforcement learning will be implemented on our mobile phones. If I see if I talk about NLP, the natural language processing, if you see a mobile phone, your keyboard has a reinforcement learning, kind of reinforcement learning, where a keyboard learns from what you types, and next time suggests you, okay, what can be the next word for you. That's the kind of reinforcement learning which is implemented over mobile phones. You are seeing that in your real life scenarios. Now taking a question of what should I do to start reinforcement learning? Sudhanshu, you need to learn a lot of supervised learning. So by learning, Dr. Kushal, can you explain supervised learning?
Okay, so when we talk about supervised learning, then we have situation like we have data with the label. For example, I want to create a neural network which can differentiate between dog and cats. So I will take some images, and when we have dog, I will label it as dog, and wherever I have a cat in the picture, I will label that image as cat. So this is labeled data. And there is the supervision, that you have a teacher to tell you that this is this thing, this is this thing. Learn 10 examples. I will give you 100 examples. After that, I will check you for 10 examples, whether you are whether you are able to identify dogs and cats correctly. So that is the workflow of supervised learning, that your data is going to be labeled data, that
So
you know what is what.
yeah. So basically, when we start a school in in a kindergarten or a first class, I think we are doing supervised learning, right?
Yes,
We are
right.
being taught. We are doing, this is A. A looks like this. We type A. So we are doing supervised learning, right? That's the supervised
Yes,
learning. If I
yes.
put it in a very layman manner, so we start our journey by supervised learning. We learn using supervised learning, and then we use unsupervised learning. So for a supervised learning, obviously you need a supervised learning, because the agent has to know something to differentiate between black and white, to differentiate between true and false. That's why neural networks, our whole mind, the mapping of a mind is a neural network. Every neuron is made of so many neurons. It's a neural network where there are nodes. Every node have their weights. Message is passed over them. They learn over that, and output is given to that. So
where in the LSTM exam, in the example of hide and seek, we saw something LSTM, that is long short-term memory. That was a neural network, type of neural network, which is specially put it for this hide and seek game.
So, and Dr. Kushal, I can see a lot of similarity between a medical, where we learn all these neurons, we learn these weights, we learn a lot of similarity between a neural network and a reinforcement learning or artificial intelligence learning. So we are trying to mimic a human mind. There should be, right. Then there are search methods in AI. You need to learn search methods in AI. Search means tree search, binary search. How to search among different anomalies, how to search and how to figure out, okay, fine, this is the right answer. I have to take it out this. I have to search among that. There are the different search methods in AI.
Like gradient descent.
Yes. And obviously you need to do a lot of coding, lots of coding. So if you are starting a reinforcement learning journey, so you need to start coding from right now in Python, and which we do at FirstUniv. In our course, we create some agents. We create these it's a part of an AI ML program where there's a course on reinforcement learning where we teach how to create intelligent agents. And someday maybe Stanshu, we can create a PUBG bot for you, and who can play for you and kill and win every time, get a chicken dinner every time for you. So you can create that. This is possible because if you go online and search, people have created bots who that bot has, reinforcement learning bot has won Mario in around 2 or 3 minutes. The Mario was made, it was a reinforcement learning agent. The Mario knew how to do those strategy, and Mario was able to get the princess in 3 minutes of 5 minutes of a game, where it for a human being, when I played Mario, I think it took me 5 to 6 years to get that princess. So it's like, you have to understand that. So it's just like that. So it's so cool. Since learning is cool, you are teaching something, and that when you teach someone, and then that program will be smarter than you. That's scary also, but let's see how it goes in future. That's the last slide for me. If you have any questions, we can take that.
Thank you, Sachin. Thank you, Dr. Kushal. I think that was very, very informative and very interesting for that matter. We do have a lot of questions. So I think we've already answered Sudhanshu's question. So Rakesh actually has a suggestion. Please have a webinar on quantum computers and tell us how it is related to AI. So I think, yeah, that's a very interesting topic, and we can definitely look into that. Yashika,
excuse me, if it is a question that how quantum computers can help in AI. So thing is that when we talk about artificial intelligence, so there is going to be search. There is a very big state space search. For example, if I have a very big neural network, I have to learn weights for it. Okay, so that is basically a searching problem. And if we talk, essentially any problem in computer science can be reduced to the state space search problem. So quantum computers have the power; they can work in parallel on many problems. So when you have parallelization, so you can do the search fast. Your network will converge fast. It will train fast. So this is how the quantum computing can help in AI.
Right. I hope that answers it, Rakesh, and we'll definitely look into that topic as well. Yashika wants to know what type of neural networks do deep reinforcement learning use. I think we already spoke about this.
Yes.
Right. So I think we can move to the next. Rohit wants to know, how do Monte Carlo algorithms work?
Monte Carlo algorithms are basically the algorithms which we work with the random numbers. Basically, simulations or random with the random numbers are called as Monte Carlo simulations. Okay, so some part of the Monte Carlo simulations are useful for AI, but this is a topic which is off from this main discussion. So we can take when we talk about quantum computing, we will definitely go for the Monte Carlo algorithm in detail.
Right. So please look out for the next session, Rohit. We will definitely cover this. And if you need an urgent answer, you can always email Dr. Kushal and Sachin. Uh, Rani wants to know what are the approaches or algorithms to
So,
solve problems in
yes, so Rani, we
reinforcement learning.
discussed about the workflow of reinforcement learning algorithms. You need to create the environment, you need to create the agents, you need to train the agents, you need to create the policy for those agents, you need to put some rewards. And the algorithms, there are so many algorithms, right? We talk about LTSM, we talked about but you can use you learn what to call CNN. Dr. Kushal talked about that. So there are so many algorithms. So you can get more information on FirstUniv website. So we talked about this. So this is how you have to understand how to create a workflow for a. So to create an environment, you have to create an agent, you have to create a policy, and we train on that.
Yes.
Right. Thank you, Sachin. Mahesh wants to know, please suggest some best online courses. I think I can answer this one. I think a good course to do is your advanced certification with AI and ML from FirstUniv. And for other best online courses, you can check out our website, firstuniv.com. We have another question in the Q&A section. Love wants to know why reinforcement is important to learn for games.
So love, it's not reinforcement is not important to learn for games. It's like, but through games we can implement reinforcement learning to learn about the different strategies in the real world. So we talk about when we saw hide and seek, there was 4 or 5 different strategies which came out: using a ramp, blocking a way, hiding the ramp. Those are different strategies. So using games, implementing reinforcement learning in the games, we can solve the real world scenarios, come out the strategies in a faster way.
Right. Thank you, Sachin. I think Ayushi wants to know what are the limitations of RL.
Okay, so there are many issues with RL right now. So they are like what agent is basically doing. It is learning from its environment. So there are not very efficient algorithm known for us to train the environments very quickly. And if you do the overtraining, it can also create trouble. When to stop the training, we don't know it yet. Okay, and there are like you want to learn policy, how to design the reward function. What is the best way to design the reward function? Like in hide and seek, the reward function was very simple. In complex environment, it's a challenge to define reward functions. Okay, so there are many issues with reinforcement learning,
Yes.
and one of the issue is also hardware. Like
Yeah.
for very complex problems, we need very faster hardware. Okay,
but again, if I implement this as it was to AlphaGo, or if I talk about StarCraft 2, it was the reinforcement learning was implemented there, and it has multiple scenarios. In AlphaGo, AlphaGo used basically a binary search tree algorithm to win over. AlphaGo can have millions and trillions of outcomes, right? So these are going, yes, but the main drawback of right now is the hardware, because, and I think maybe Dr. Kushal is working on a lot of quantum computing, so maybe the quantum computing can help to resolve those hardware gaps between.
So there is something which is known as representation learning. Okay, so knowledge representation. So that is a very big challenge. How to encode your agents and the knowledge in the system in an efficient way so that it can process faster. Okay, embedding, how to embed the knowledge. Embedding is a challenge across the whole spectrum of the artificial intelligence, not only just in reinforcement.
So this means reinforcement learning doesn't only cater for the engineers, it can cater for the managers also, who can decide the policies, who can create the strategies, and it can be implemented by the coders. So it's for win-win for both the fraternities, this kind of course, right?
Right. Thank you, gentlemen. Are there any more questions? While we wait for more questions, I think I'm just going to take a minute here to thank everyone for participating and, of course, engaging and asking their questions. And as we speak about the course, there is some good news to share. Our partner university, Shoolini, has now cracked the global top 200 in THE's impact rankings. This is a very, very big achievement. And considering the university is a little over 10 years old, and we've beat some of the best legacy universities in the country. So, that is just the kind of testament that we need for our partners here. And as you all know, this course will get you industry projects, will get you 8 different certificates, and we are also putting in a placement guarantee. So upon your course completion, we will prep you for interviews and make sure that these certifications also get you a job opportunity. If there are no further questions, okay, I think there is one. Ayushi wants to know, can we say that these agents are intelligent than humans?
Yes,
No, we can.
Kushal says no. I say yes. It's fine. It's fine, because I look in a future prospect. So in future, yes, they can be intelligent than humans, because if they when they as I spoke about, as I asked Dr. Kushal. So Dr. Kushal said a person to come out with a learning strategy will take years, but for a human, for a agent it takes hours. So if agent can learn 3 years in 2 hours, then he can be more intelligent than a human being in future, obviously. Dr. Kushal, yeah, you can explain a no. I explain my yes.
Yeah. So my point is that I agree with Mr. Sachin sir, that the agent is learning very quickly. Okay, he is an efficient learner. Okay, it can learn very fast and it can remember its pitfall. Okay, but an agent at present cannot create like new agent. Okay, it cannot create new environment. So there, that is the place where it is lagging, which was my part of no. And the part of yes of sir is that it can learn very fast. Like for example, it can learn Mario in 3 minutes. Okay, but it will take me 6 years. Okay, so in the so I have explained you both knows and yes where it is
So
better
Kushal,
than human, where it is
you
not.
about the human intuition. I think we were talking about the human intuition, which
Human
machine
intuition,
lacks.
yes.
But okay, fine. We can debate someday else. Machine can
Yes.
have an
So these are
intuition in future. Yeah,
okay.
All right.
So
Let's just
these are philosophical questions of artificial intelligence. Actually,
absolutely,
what is
absolutely.
intelligence? There are the philosophical questions actually.
Yes.
okay. Let's just hope that it doesn't become too dangerous. And it's not very comforting when Sachin is saying all these things with the Matrix background, but I think we'll take it.
That
Uh,
was the purpose for it. Yeah.
Brilliant. I think with that, we can take everyone's leave. Thank you so much, everyone, for joining. We'll be back again next week. And thank you so much, Sachin and Dr. Kushal. I think this was very interesting and very fascinating for our users. And if there are any questions, please do let us know. Uh, your individual counselors would be getting in touch with you again. So thank you so much and stay safe, everyone. Have a good weekend. Bye bye.